We're going to practice evaluating function at x values and solving the function for certain y values. And I'm going to start with this table right here and just work my way through the table. So first things first, it says, where is the y value which matches the x value of 1? So I think of it this way. I think of my x value of 1 as a vertical line. See, this represents all the x values of 1. And where is the function overlapping with that line? Well, nowhere. There's nowhere on this function, which is in blue, right? Let me be real clear here. This f of x, that's my function. There's nowhere where that function has an x value of 1. It just doesn't exist. So what we put there then is dne, because it does not exist at an x value of 1. Now if I try x equals 7 as a difference idea, or x equals negative 7, that's over here. I see the x values of negative 7 are on that line, and my function right here has a y value of negative 1. So I will put that in here for my y value. And you work your way through the problem one step at a time this way. I'm going to move on to the y values now, these lower parts, because I think there's some tricks to that you should be aware of. So if you look at this, I'm going to do this one right here. Negative 6, where does my function equal negative 6? Well, you can imagine drawing a horizontal line and just seeing where that intersects with the function. And you might say, oh, hot dog, I've got 2 spots, right? One of them is right here, and one of them is right here. Those both have y values of negative 6. But there's something different about those 2 spots. One of them is a dot, which in algebra we use to mean, yes, the function definitely exists at this point right here. So I can say x equals 0. That's great. But one of them is an open circle, and that's located at x equals 2. So if I put this as my answer, yeah, I mean, as a teacher, I would know you're looking in the right place. But the problem is we've got to understand what that open circle means. That means the function does not actually exist at 2. Okay, so it means the function exists almost at 2, like right here at 2.1. Yeah, the function is fine just there, but not at 2 itself. So you got to watch out for those open circles. They mean the function does not exist exactly at this place. So here's my answer to this one. 0. That's it. X equals 0, y equals negative 6. Now it is possible to have more than one solution. Like let's say I had chosen negative 5, for example. If this were negative 5, this next one, where would the function equal negative 5? Well, here's a spot. I don't know what that is. Negative 0.2 or something. And then here's another spot, 3. So I would say negative 0.2, comma 3. Those are my 2 solutions in x. But that is not the case. That was just a what if. Let's look at the last actual example. So this is if y equals 5. Well, y equals 5, you can imagine that's a line. Let me get my pen back here. That's a line that goes horizontally like this. Those are all the y equals 5 values. And the blue function simply never reaches that height. So this is another case of dne. There is no x value which produces a y value of 5.